Hi, my name is John. I will be going over Calculus 2.3 with Mr. Powers, Wayne Powers class for part of your homework. Let's get started. Let me share my screen with you first. Okay, so this is a book that you'll be using. It's James Stewart Succeed. Okay, and here's 2.3. Made it nice and big so that you can see it up. Should make this a little bit bigger as well. So given that the limit as x approaches 2 of this function f equals 4, the limit as x approaches 2 of this g function equals -2, and etc. Find the limit that exists. If the limit does not exist, explain why. So let's get started right away. Where's my pen? There it is. 1a. What's the limit as x approaches 2 of f of x plus g of x? Well, this is pretty simple. The limit of its sum becomes the sum of its limits. The sum of its limits. In other words, this becomes the limit as x approaches 2 of f of x. You basically just distribute the limit to both terms. Remember, a term by definition is addition or subtraction. So the two basic most operation, which is either to add or subtract, is called a term. If you have 2x plus 3, the first term is 2x, and the second term is plus 3. Okay, so this is called a two-term or binomial. Plus the limit as x approaches 2 of g of x. Well, according to my function right here, the limit as x approaches 2 of the function f of x equals 4, plus the limit as x approaches 2 of g of x, let's look at right here, is -2. 4 plus -2, positive 2. Oops, there it is. For part B, you take the limit as a inside as well. So for part B, excuse me, this was for part A. Part B, the limit as x approaches 2 of g of x quantity cubed. So same thing as the limit quantity of the limit as x approaches 2 of g of x and m bracket cubed. We know that that is equal to -2, right? And there it is right there. What's -2 cubed? Well, cubing, sorry about that. Cubing means -2 times -2 times -2 by definition. -2 times -2 times -2. It's going to be negative times a negative is positive times a negative is negative, -8. There's your answer for part B. Part C is a little bit tricky. Actually, number 3 is not tricky. I believe part D might be a little bit tricky. Anyways, let's try to work this out. Erase this first. So part C is the limit as x approaches 2 of the square root of the function. So we could put the limit on the inside. That's the same thing as the square root of limit as x approaches 2 of this function f of x. And the definition, the limit as x approaches 2 of f of x is located right here, which happens to be 4. So we're going to replace it with 4. That becomes square root of 4, which becomes 2. Only positive 2. The reason being is because when you take the square root of both sides of an equation, let's suppose x squared equals 4. When you take the square root of both sides of an equation, x equals plus or minus 2. The square root of 4 is 2. If you plug it in, -2 squared is also 4. Positive 2 squared is also 4. That's why when you take the square root of both sides of an equation, you have to put plus or minus on one of the sides. Okay? Part D gets a little tricky. Not too bad though. The limit as x approaches 2 of 3 f of x divided by g of x. Well, you can take the limit to the numerator and the denominator as well. That becomes limit as x approaches 2 of 3 f of x. This means 3 times f of x, okay, divided by the limit as x approaches 2 of g of x. We know that if it's a constant times a function, the constant can always come out to the front. That becomes 3 times the limit as x approaches 2 of f of x divided by the limit as x approaches 2 of g of x. We know that that right there, that's equal to 4. And that right there, according to this graph, not graph, sorry, the given information is going to be negative 2. That's going to be negative 2. So it's going to be 3 times 4, which is 12 over negative 2. Positive times negative. I like to put signs here just in case, like is it positive or negative. Sometimes. Positive 12 divided by negative is going to be negative 6. And that's your final answer. You should be able to do number E, H. Oh, by the way, when you have a division by 0, it's D and E, right? It's never, ever, ever allowed. So part E will be D and E because division by 0 is not allowed. Does not exist. Okay. Next. Number 2. Let's look at, do you want to look at, let's pick about 3 of them. Let's do part A first. The limit as x approaches 2 of this function plus g function, right? We can distribute to this inside, okay? It becomes the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. Well, according to the graph, because they don't give you equations like here, given information, they give you a graph, right? As x approaches 2, here's 2, x equals 1, x equals 2. From both sides, my output or my y value is going to be going towards 2, right? Here it is. Here's the origin, by the way, because we know that that's the y-axis. This is the x-axis. So here's the origin. So as x approaches 2 from the right and left, it's the y output is going to be 2. So that's going to be 2. What about my g function? As limit as x approaches 2, here's my g function. 1, 2. From the right and from the left, my y value is approaching 0 because it's not going up and down any. If it's approaching 1 from the right, it's going to be 1. If it's approaching 1 from the left, it's going to be approaching 2. Got that? So in other words, that's going to be approaching 0 from plus, so it's going to be just 2. That should help you to finish some of these questions right here, just 2 of them. Let's try this one. Part B. The limit, I'm just going to distribute this inside the function. The limit of the sum, because the sum of its limit. Limit as x approaches 1 of f plus the limit as x approaches 1 of g. I'm not going to write g of x or f of x. Well, as x approaches 1 of this function f, here's your f function. Here's 1 from both directions. From the left, it's approaching 1. From the right, it's approaching 1 as well on the output. So that's 1. What about g function? At 1, from the left, as I said earlier, my y value is approaching 2. From the right, it's approaching 1. My output is approaching 1. From the left, again, it's approaching 2. From the right, it's approaching 1. So if it's approaching 2 different numbers, it's D and E, right? Does not exist. So what's 1 plus does not exist? It's just D and E. Does not exist for part B. Part C, D, the limit of its product becomes the product of its limits. The limit of its product means something that's being multiplied, becomes the product of its limit. Limit as x approaches 0 of function f times the limit as x approaches 0 of g of x. If the limit of its quotient becomes the quotient of its limits, etc., etc. Okay. Let's do this, number 3, 4, 5. I'm going to do this a little bit rigorously if I can. Let's just pick one of them. And the reason why is, as part of your homework, if you look at the book, again, where's your book? There it is right there, right? If you look at the examples from the book, they will really, really help you out. Because a lot of these examples, I was going through them this morning, or I'm sorry, last night, before I had my first student. And the books were very, very helpful for this type of example, okay? We learn by example, so please look at the examples. What's the limit as x approaches negative 2 of this function? 3x to the 4th plus 2x squared minus x plus 1. The limit of its sum or difference, we just distribute to all terms. Remember, a term is divided by, separation by adding or subtracting. So there are first term, second term, third term, and then fourth term, right? Remember, separation by of adding and subtracting, which is the two most basic operations. Got it? Sometimes what I like to do is at the very beginning to help you guys out. I like to put a little, here's my first term, here's my second term, here's my third term, and here's my fourth term. This technique was usually done in like 9th grade or 10th grade, just in case. Okay, JIC. What is JIC again? Just in case. Okay, like I said, I use a lot of TLAs here. So we distribute that in. The limit as x approaches negative 2 of 3x to the 4th plus the limit as x approaches negative 2 of 2x squared minus, there's a minus right there, the limit as x approaches negative 2 of x plus the limit as x approaches negative 2 of 1. Here, when it's a constant times a function x to the 4th, the 3, this 3 right over here comes out to the front. This 2, since it's being multiplied by 2, comes out to the front as well. So that becomes 3 times the limit as x approaches negative 2 of x to the 4th plus 2 times the limit as x approaches negative 2 of x squared minus, there's a 1, I don't really care about that 1, fine, 1 times the limit as x approaches negative 2 of x, and then plus, the limit of a constant is the constant itself, just plus 1, okay? Well, as x approaches negative 2 to the 4th is going to be 2, 4, 8, 16. I use my fingers. How many fingers do I have? I have 10 fingers. I'm sorry, I meant how many fingers do I have up? I have 4 fingers up. 1, 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64, 120, 256, 500, 1024, something like that. So negative times a negative times a negative times a negative is positive. So it's going to be 3 times 2, 4, 8, 2, 4, 8, 16. 16 plus 2 times negative 2 squared is going to be 4. Let's put parentheses on this. Minus 1 times negative 2 and then plus 1. 3 times 16 is 48 plus 8 plus 2 plus 1. I'm going to add these up first. That's going to be 10 right there. 58, 59. Whoop, there it is. That's my final answer. So in this right here, for number 4 and number 8, You just distribute the limit to the inside and rigorously work it out, just like this problem right over here for number 3. Oops, here it is, number 3. Okay. You should be able to do these fairly well. Now it gets a little bit difficult. The algebra is a little bit tricky on these questions. You got to work these out rigorously if you can for number 3, 4, and 5. Yes, Mr. Powers is going to say something like, yeah, you can just plug in -2 in here, here, and here, evaluate, but it's more important to rigorously work it out. Okay? I'm not sure if he's going to say that or not. I'm just taking a guess. Okay, so let's look at number 11. How do we do number 11? Number 11 says x squared plus x minus 6 all over x minus 2. What's the limit as x approaches 2? Well, if you plug in 2 in here, 2 minus 2 is 0. So division by 0 is not allowed. So you cannot put 2 in for x. So what do? We can only do one thing. Look at the numerator, x squared plus x minus 6. You can use a diamond if you want. You can factor it whichever way you want. Ask me if I care. I don't care. So factoring this in the numerator, it doesn't really matter how you factor using the diamond or regular method. It's going to be x plus 3 times x minus 2 all over x minus 2. And what you notice is the x minus 2 will cancel out. If you can cancel the factors of x minus 2, there's a hole at x minus 2 equals 0 or x equals positive 2. There's a hole there. So the function looks something like this. Y equals just x plus 3. To graph this, it starts off at 3. Your y-intercept as a slope of 1. And x equals 2, 1, 2. Going up to my y value, there's a little hole right there. If you graph this out, this function right here, you will not see the hole on your graph. There is a certain way you can find this hole on your graph. It will actually show it in the Windows section. But for now, if you look at this equation right here, y equals x plus 3, that's your equation of this line right here. Okay, there's a hole at x equals 2. So from the left and from the right, what's my function? Now you can plug in 2 in for your x. X is 2, 2 plus 3 is going to be 5, and that's your final answer. Okay, your output is going to be 5, where your input is 2. At the very beginning, you cannot plug in 2, but because of the algebraic manipulation that we did, where we factored and canceled, then we can plug in 2 for your y value, x value, to get your output. You can do the same thing with number 12 as well. You're going to have to factor that and factor that as well. And then something will cancel. By the way, if you plug in -4 squared, it's going to be 16. 3 times -4 is going to be -12 minus 4. And so you have division by 0. So you cannot plug in -4. You have to factor the numerator and the denominator. Once it cancels, then you can work it out. Let's just work it out. Number 12. What's the limit as x approaches -4 of x squared plus 5x plus 4 over x squared plus 3x minus 4. The factors in the numerator are going to be x plus 5, sorry, x plus 4, x plus 1. I know that it has to multiply to 4, and I know that these have to add up to 5. As well, there's going to be x plus 4, x minus 1. It has to multiply to -4, has to add up to positive 3. Oh, the x plus 4 cancels out. These factors cancel out, you end up with x plus 1 over x minus 1. Now you can plug in negative 4. Negative 4 plus 1, let's just write it out. Over negative 4 minus 1. Evaluating the numerator, you get negative 3. Evaluating the denominator, you get negative 5. Negative divided by negative is positive 3/5. There's your final answer. It's already reduced. For this problem right over here, you have to, since you have a polynomial in the numerator, you have to factor out something. What are we going to factor out? Think about it. Think about what you're going to factor out here as well. And then you're going to cancel those out. And then you can plug in 0 afterwards. Let's do part B. Part B is a little bit tricky. The algebra is going to be horrendous on this. Part B. The limit. Remember, 70% of your errors in calculus, I'll write this down for you. 70% of errors in calculus is going to be algebraic in nature. So you got to really be careful about the algebra. Okay, 20% is going to be calculus concept, and about 5% is going to be erroneous. Erroneous meaning 2 plus 3 is equal to 6. That's erroneous because it should be 5. And the rest of the 5 is somewhere. Okay. So anyways, since most of your error is going to be algebraic in nature, we're going to have to work with the algebra quite a bit on this one. And this one, no, not that one. This one's pretty simple. This one as well. And this one, you're going to have to work out the algebra. So let's look at the algebra on part B. Limit as x approaches 0 of 2 plus x cubed minus 8 all over x. I'm going to erase this, okay? First of all, 2 plus x cubed. Let's algebraically work that out. 2 plus x cubed, by definition, means 2 plus x times 2 plus x times 2 plus x. I'm going to multiply 2 plus x out first. 2 plus x times, if I distribute this, I get x 4 plus 4x plus x squared. Remember, I had to FOIL this out. I'm going to multiply 2 times and distribute 2 to the 4. You get 8, 2 to the 4x plus 8x, 2 to the x squared, which is plus 2x squared. Distribute this out. X times 4 is 4x plus 4x. Notice how I use the vertical format right here. X times 4x is plus 4x squared. X times x squared is plus x cubed. That's going to be something as 8 plus 12x plus 6x squared plus x cubed minus 8 all over x. Remember, if I put x equals 0 in here, I get a division by 0. And by the way, if I put it in the numerator, 2 plus 0 is 2, right? 2 plus 0 is 2. 2 cubed is 8 minus 8, you get 0. So when I evaluate the numerator, I also get 0. 0 divided by 0, oh, I'm really sorry, that's a really sad face. That's not even undefined. That's like, it's everything and nothing at the same time. I'll explain this maybe a little bit later. But anyways, so when you have 0 divided by 0, it's a really, really sad situation. By the way, you can solve this using the L'Hopital's rule later on. So the 8's cancel here. You end up with 12x plus 6x squared plus x cubed. 12x plus 6x squared plus x cubed all over x. Now, there's something you can do with the numerator. You can factor out an x here, the first term, the second term, and the third term. Factor out an x, you end up with 12 plus 6x plus x squared all over x, right? If you're not sure, just distribute that. 12x plus 6x squared plus x cubed. Make sure you distribute factor back and forth so that you kind of know what's going on. The x's will cancel. Those factors will cancel. Now you can plug in 0 for x. You end up with 12 plus 6 times 0 plus 0 squared. You end up with just 12. That's your final answer. A little bit tricky. You have to learn to distribute those cubes. You could have used binomial expansion, which you should have been taught last year by Mr. Villano, but binomial expansion is a really hard formula to memorize, especially like if you have like fifth power, you have to use binomial expansion, but to a third power, I would just distribute right over here at the very beginning, okay? Part C, let's look at part C. Part C is pretty simple, but I will have to explain how to do part C. Part C says something like this. The limit as x approaches -3 of y squared, not x, sorry, y, because it says y right there, plus 4y plus 3 all over y squared minus 9. If I plug in -3 squared, you have to have a quantity around negatives. Make sure that the whole thing squared, right? -3 squared is going to be 9. 9 minus 9 is obviously 0. So you don't want to do that now. But this binomial is very special. In fact, it has a very, very special name. This is called the difference of squares, right? See that difference of squares? Oh, ding ding, it should ring a bell. You learned it in Mr. Power's class, 10th grade, I believe, Math 2, as well as, what do you call it, junior year for most of you, in Mr. Bolano's class, right? So, the difference of squares always factors to its conjugates, right? It's going to be y plus 3, y minus 3. We know these are called conjugates, excuse me. We know that these are called conjugates because one has a plus, one has a minus. And the numerator, that's also factorable. It's going to be y plus 3 and y plus 1. If you just distribute this out by folding, 1 times 3 is going to be 3. 1 plus 3 is going to be 4. You could use the times as well if you want. Okay? Oh, what observations do you see? You see that the denominator, y plus 3 factor, cancels with the y plus 3 factor. You end up with y plus 1 over y minus 3. What's the limit as y approaches -3? Now you can plug it in. Plus 1 over -3 minus 3. -3 plus 1 is -2. -3 minus 3 is going to be -6. It's going to be positive 1/3. Remember, negative divided by negative is positive. 2 over 3 reduces to 1 over 3. 1 over 6. I'm sorry. 2 over 6 reduces to 1 over 3. Okay? I'm going to switch this out a little bit because I'm on my and by the way, you can support my Patreon if you want. Actually, I'm just kidding. I don't do any Patreon. So, like I said, I don't do Patreon. Anyway, so let's look at some other problems. We did this one. Let's look at this one. It's a little bit tricky, part D. You have the limit as x approaches 1 of x cubed minus 1 over x minus 1. The denominator, you can't do anything about the denominator, x cubed minus 1. This is called, does anybody remember what this is called? Difference of cubes this time. Difference of cubes. Does anybody remember the difference of cubes formula? A cubed minus b cubed is equal to, with the first factor is going to be a minus b. You drop everything without the cube. The second factor is going to be you square the first one, change the sign from a minus to a plus, we multiply these two, a, b, and then what do? Plus b squared. It's SOAP, everybody. SOAP. Same sign, opposite sign, always positive. That's how you can tell. SOAP to get the signs correct. Same sign, opposite sign, always positive. So, isn't this the same thing as x cubed minus 1 cubed? That's the same thing as x cubed minus 1, right? So using this formula, I'm going to go pretty fast on you guys, so pay attention. X minus 1 times square this one, which is going to be x squared. Change the sign, it's going to be plus. 1 times x is going to be x. Always positive. 1 squared is going to be 1. You can slow that down if you want. Over x minus 1. Wow, this factor cancels with that factor. Now you can plug in 1 if you want. That 1. 1 squared plus 1 plus 1. 1 squared is 1. Plus another 1 plus another 1 equals 3. There it is. This is a little bit tricky. I'm going to do actually both E and F for you guys because they get much more difficult. Limit as h approaches 0 of 1 over 2 plus h minus 1/2 all over h. There's several ways you can do this if you want. You can have common denominator here, going from a complex fraction, because it's complicated, to a simple fraction. There's also another way, which is a lot easier once you learn how to do it, but I noticed that my student had a difficult time using the bus that fraction method, or BTF. So we're going to do the long way. The common denominator between 2 plus h and 2 is LCD, least common number, happens to be 2 times 2 plus h. Okay? So here, the first term I have to multiply by 2, top and bottom. Here, I'm going to multiply by 2 plus h. Okay? And let's see what we get. Because remember, when we multiply top and bottom by the same number, it's the same fraction. So here you get the limit as h approaches 0 of 2 over 2 times 2 plus h. Minus 1 times 2 plus h is going to be 2 plus h all over 2 times 2 plus h. And instead of dividing by h, I'm going to multiply everything by 1 over h. Because remember, if it's in the denominator, same thing as multiplying by the reciprocal, right? I don't know if you guys remember that or not. Or if you could say it's divided by h, remember the division changes into a multiplication and you reciprocate that. Looking at this, 2 minus this quantity, well, the denominator is going to be 2 times 2 plus h. 2, you have to distribute the negative. Everything here is minus 2 minus h. So these cancel. Times 1 over h. And the, oh, look at that. The minus h and the positive h also cancels to a 1 and negative 1 as well. You end up with negative 1 over 2 times 2 plus h, whatever is left. Now you plug in 0. Because now 2 times 2 plus, what's 2 plus 0? It's 2 times 2 is 4. It's going to be negative 1/4. That's your final answer. Like I said, there is an easier way to do this. You can bust that fraction, but we'll talk about this a little bit later. Okay, so that's the algebra on part E. Part F, a little bit tricky. you have this function, the limit as t approaches 0 of the numerator. I'll just write out for you. Limit as t approaches 0 of the square root of 7 plus t squared minus square root of 7 all over t squared. If I plug in 0 in here, 7 plus 0 squared is going to be just 7. Square root of that minus square root of 7, you end up with 0 over 0 squared. I'm so sorry. Sad face. So what we're going to have to do is we're going to have to manipulate this a little bit. Okay? What do? We multiply by the conjugate of this. What did I just say? Since it's a binomial, we're going to multiply the numerator and the denominator by the conjugate of this. The conjugate of square root of t plus t squared minus square root of 7. It's going to be, I'm going to write it out for you. It's going to be square root of 7 plus t squared plus the square root of 7. Since we multiply the numerator, I can multiply the denominator. 7 plus t squared plus the square root of 7. Okay? Remember, I can multiply the top numerator and the denominator by the conjugate of this right here, because it's a binomial, very special binomial. Let's distribute this out. See what happens. What's the square root of 7 plus t squared times the square root of 7 plus t squared? Well, we know that when you have to take the square root and then we square it, it becomes itself. Limit at, sorry about that, t approaches 0 of 7 plus t squared. The outer and the inner will always cancel when it's multiplied by the conjugate. So I really don't care. It's going to be plus this, blah, 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 minus blah, blah, blah. When you multiply these out, the conjugates always cancel in the outer and inner. And then lastly, negative square root of 7 times positive square root of 7. It's going to be negative 7. So this is FOIL. Don't forget to fold this out. That's what's so special about conjugates, right? It always factors to its difference of squares. By the way, this right here, 7 is a square value because this would be like square root of 7 squared. Anyway, so you have to know what 7 plus t squared minus 7 all over t squared. Give me an observation. Can you figure out what the observation says? Well, you have 7 plus t squared minus 7. The 7 is going to cancel out. And so you end up with t squared over t squared. The limit as t approaches 0. T squared over t squared is 1. The limit as t approaches 0 of 1 is just 1. That lonely one. Just kidding. Good luck with your homework, and I'll try to put more solutions out for each problem on these, okay? And I'm not going to put do every single problem for you guys next time. I'm just going to do as much selected problems. Okay, take care and good luck on your homework.